Hello everyone. Today we will make a revision about the lessons that we studied before, like 4.6, 5.1, 5.2, 5.3 and 5.4. Starting with the lesson 4.6, congruence in right triangles. Let me remind you with the theorem of the congruence in right triangle. We said at the first that the hypotenuse is the longest side that opposite to the right angle, as you see here, and the other two sides they are called legs. And our theorem, HL theorem, hypotenuse leg theorem, we said if we found in the two triangles, the two right triangles, the two congruent hypotenuse, and there is one pair of congruent legs. That means by looking at the pairs of the triangles, the right triangles here, which two triangles are congruent by the HL theorem, the hypotenuse leg theorem. Here we have in the first triangle LMN, here we have the hypotenuse 5 and the leg 3, and the other triangle OQP, we have also the hypotenuse OP5, like the hypotenuse here LN is 5, and the two legs, the corresponding legs, the same length. Then both of these two triangles are congruent by HL theorem, hypotenuse leg theorem. But the last one here, we have only two legs. There is no hypotenuse length like the first two triangles. Then the triangle LMN congruent to the triangle OQP by HL theorem. By looking at this question, the given is an angle PRS and angle RPQ are right angles. SP congruent to QR, as you see here in the given. Prove that the two triangles PRS congruent to the triangles RPQ. How to prove that the two triangles congruent using the given? We will make two column proof. At the first, we will write the statement by writing as usual the given. Here we will write the given angle PRS and angle RPQ are right angles, as we see here in the given. This is called the given, and also SP congruent to QR. The next statement that the two triangles, triangle PRS and the triangle RPQ, right triangles. This is definition of the right triangles. And also we have that PR congruent to itself, congruent to PR. This is by reflexive property of congruence. Then here we have in the given, we have the hypotenuse. The two hypotenuse here are congruent. The side QR and the side PR, the two hypotenuse in both of the two triangles are congruent, and the leg here PR congruent to itself by reflexive property. Then the two triangles are congruent by HL theorem. The next lesson, mid segments of the triangle. Here let me remind you with the mid segment. The mid segment is the segment whose endpoints are the midpoints of the two sides of the triangle, as you see here. If we have two midpoints here like this, two midpoints, then this segment that joins the two midpoints, this is our mid segment. And the third side, this is called the base, the opposite side to the mid segment. What is the relation between the mid segment and the base? We said we have theorem said that the mid segment equal half the base and parallel to this base. Then this is our mid segment and this is our base. Then the mid segment equal half the base. Here find the length of the mid segment. If you know that the length of the base 46, then the mid segment half this base 46, half 46 equal 23. Then the mid segment length is 23. Find the length of the mid segment and the base. Here we have the mid segment, as you see, is an equation 5x minus 1, and the other one is also an expression 6x plus 10. We know that the mid segment equal half the base. Then 5x minus 1 equal half 6 plus 10. You can solve this equation by multiplying both sides by 2, or you can find half 6x is 3x and half 10 is 5. By solving this equation, we will get that 2x minus 1 equal 5, then 2x equal 6, then x equal 3. By making a substitution in both of them, here 5x minus 1, then 5 multiply 3 minus 1, then equal 14. The other one here, if you made substitution, also you will get that 6 multiply 3 plus 10, this equal 28. Then the mid segment is 24, and the base is twice this mid segment equal 28. Let's make a revision about the third lesson 5.2, perpendicular and angle bisectors. We said before that we have theorem for that. For the perpendicular bisector, if we have a point on the perpendicular bisector, then this segment, then any point on this line or this perpendicular bisector is equidistant from the end points of this segment. Then again, if we have perpendicular bisector, any point lying on the perpendicular bisector equidistant from the end points of this segment. And the converse of the theorem, if you found any point on a line like that and equidistant from the end point, then the points here lying on perpendicular bisector. Here we said if A lying on the perpendicular bisector to CD, then the segment C, the segment here from this point on the perpendicular bisector, equidistant from the end point from C and from D. And also from here, from the point B, it will be also equidistant, because here the points lying on perpendicular bisector to the segment CD. What about the angle bisector? If we have an angle bisector that divides the angle into two equal halves, any point on the angle bisector equidistant from the sides of this angle. And the converse of the theorem, if you found a point on a ray like that, if this point equidistant from the sides of this angle, then this ray is an angle bisector. Let's solve this equation. Let's solve this example. CD is perpendicular bisector, and here we have the given CB equal 5. Let's find the CA and DB. Since here we have perpendicular bisector to the segment AB, then this point C equidistant from the end points A and B. Then CB equal CA equal 5. And also here D lying on the perpendicular bisector, then DA equal DB equal 6. How to solve this question? Here we have an angle bisector. Using the angle bisector theorem, then from the point F here supposed to be equidistant from the sides of this angle C. Then FD equal FB. By making a substitution, we will use here 2x plus 5 equal 7x minus 35. And by solving this equation, we will get that 5x equal 40 and x equal 8. Then FB equal FD equal 21. The fourth lesson 5.3, bisectors in triangles. We said here the angle bisectors, the perpendicular bisectors like this XP and YP, ZP, all of them here perpendicular bisectors. The point of intersections of the perpendicular bisector, or the point of concurrency of the perpendicular bisectors here, equidistant from the vertices. and the point of intersection here is called circumcenter. Then the point of intersections of the perpendicular bisectors, like the perpendicular bisector PX, PY, and PZ, here all of them they intersecting at the point P, then equidistant from the vertices, then PA equal PB equal PC. Here the circumcenter or the point of intersections of the perpendicular bisectors may be intersecting inside the triangle like the acute, or on the triangle like the right triangle on the midpoint of the hypotenuse, or outside the triangle like the obtuse triangle. How to find the coordinate of the circumcenter? This is right triangle. We have given vertices A, B, and C. Let's graph these points, point A, point B, and point C, and connect these points to draw the triangle. We said perpendicular bisector. That means this perpendicular will pass through the midpoint. Then let's find the midpoint of this side. Then this is our midpoint, and we can draw vertical line or perpendicular from this midpoint. And also from here, from the other side, we can find the midpoint and draw the perpendicular bisectors, and you will find both of them intersecting on the midpoint of the hypotenuse. Then the coordinate of our circumcenter here, this equal 6, 5. Or you can solve it by another way, by finding the equation of this line, the vertical line, which is x equal 6, and the horizontal line is y equal 5. Then we will get the same circumcenter 6, 5. What about the angle bisectors? This is PC is an angle bisector, PA, PB, angle bisectors. They intersecting at point P. This point of concurrency or the point of intersections equidistant from the sides of the triangle. That means PX equal PY equal PZ. They are equidistant from the sides of the triangle. And this point of intersection, we said this is called the incenter. The point of intersections of the angle bisectors is called incenter. How to find the incenter from this problem? We know that the incenter equidistant from the sides of the triangle. That means here, by looking at this triangle, here GE equal GD equal GF. Then we can make substitution that GE equal GF, then 2x minus 7 equal x plus 4. By solving this equation, we will get that x equal 11. Then by making a substitution in any equation, we will get that the length of GD or GF equal 15. The fourth lesson, medians and altitudes. The median, we know that the median is the segment that drawn from the vertex to the midpoint of the opposite side. And here we have if we have midpoints intersecting in the triangle, the point of intersections of the medians, as we see here, is point P, is called the centroid. This centroid is 2/3 the distance from the vertex to the opposite side. That means BP equal 2/3 BL, and CP equal 2/3 CJ, AP equal 2/3 AK. Let's solve this question. P is the centroid of our triangle. YV equal 12. Find YP and PV. We know that the distance let's find the distance of YP, the length of YP. We know that the centroid equal 2/3 YV, Then by making a substitution, then yp equal 2/3 12, 2/3 multiplied 12, then yp equal 8. Since we know the length of yp equal 8 and we have in the given yv equal 12, by making a substitution here, we will get that pv equal 4, 12 minus 8. Let's solve the next question. In triangle JLN JP equals 16, find PM. Here we know that the median JM, it has two segments JP and PM. JP equal 2/3 the median JM. Then by writing that JP equal 2/3 JM, we know that JP equals 16. Then by making a substitution, then 16 equal 2/3 JM. By moving 2/3 to the other side by multiplying reciprocal, then JM equal 3/2 multiply 16, then JM equal 24. How to find the PM? We know the length of the median JM 24, and we know that JP equals 16. By making substitution here, then PM equal 24 minus 16, then PM equal 8. The altitude or the height. The altitude, as we know, this is perpendicular segment to the opposite base or the opposite side. From the vertex to the opposite base is perpendicular. And maybe this altitude inside the triangle like the acute, or one of the two legs like the right triangle, or outside the triangle like the obtuse triangle. The point of congruency or the point of intersection of the altitudes in the acute triangle intersecting inside, but the right triangle intersecting on the right angle, the obtuse triangle intersecting outside the triangle. And the point of concurrency or the point of intersection is called orthocenter. How to find the orthocenter from the given vertices like this triangle ABC? Here we can find the altitude, the two altitudes from the point B to the opposite base AC, to the opposite side AC. Since AC is horizontal, then the altitude is vertical line from the point B, and we know that the equation of the vertical line is equal x equal 2, because this is drawn from the point B. Then the equation of the first altitude is x equal 2. Let's find the equation of the second altitude. If we draw this altitude from the vertex A to the opposite side BC. At the first, let's find the slope of the side BC. By finding the slope of the side BC, 3 minus 7 over 6 minus 2 equal negative 1. Then the slope of the altitude is opposite reciprocal. This equal 1. Then by using the point slope form, y minus y1 equal mx minus x1, and making a substitution that x1 y1 is our point A 1 3, then we can write the equation y minus 3 equal 1 x minus 1. By making it simplifying to this equation, we will get y equal x plus 2. Let's solve the two equations. X equal 2, this is the first equation, and the second one, y equal x plus 2. By solving the first and the second equation, we will get that y equal 4. Then the point of intersection or the orthocenter of the two altitudes is 2, 4. This is our orthocenter. Thank you for listening and have a nice day.